Okay guys, welcome to mechanics. We're looking at exercise 2C. Read the introductory material please. Weight and motion due to gravity. Let's look at what we know here. Well, we have a wrecking ball. It's got a mass of 1 ton. It's dropped onto a concrete surface to crack the concrete. It needs to strike the ground at 5 meters per second to cause a crack. Find the minimum height from which it must be dropped. So we're trying to find S. We know that u, the initial velocity, is 0, I think, and v, we want it to be equal to 5. We know that the acceleration due to gravity is minus 10. Although actually, if we're just dropping it, the acceleration will be 10 because it's in the same, going in the same direction as the ball, so we're not throwing it up. So yeah, I'm going to use that as a positive 10 actually. And okay, well, I think we have all we need here. Let's just have a quick check. Okay, I reckon we can use v squared equals u squared plus 2as. So this should be 5 squared equals 0 squared plus 2 times 10s. So 25 over 20 equals s. So s is equal to, what is that? 5 fourths or 1.25 meters should be the answer for that one. Let's just check that we have that one correct. What number is this? We're on 2C. Question number 6. Yeah, 1.25 meters is correct. So that one wasn't as hard as I was expecting. Let's move down a bit and have a look at number 12. So the second question I'm going to do is number 12. We have a ball of mass 0.3 kilograms and we throw it up with a speed of 10 meters per second, and it's experiencing air resistance of 0.15 newtons, and then we know that the ball lands on the ground, which is 1.2 meters below our starting point, and we've got to find the speed with which it hits the ground. So let's do the upward movement first. So we know that we have a particle and it's traveling up, but we know that there's the force of gravity on it, which will be 0.3 g, where g is 10, right? So it's 3 newtons. And we also have air resistance as it's traveling up of 0.15. Okay. Now, if we want to find the acceleration, what we do is we chug this into this formula. So we look at all of our forces, and since we're going to say the positive direction is up, so we're going to have a negative 0.3, whoops, that's a bit messy, negative 0.3 g, and then we're also going to have a negative 0.15 because the air resistance is opposing the motion up. And that's going to be equal to the mass of our object times its acceleration. Now that means negative 3 minus 0.15 equals 0.3a. And when we chuck this into our calculator, we're going to get a negative number, negative 3 divided by 0.3, negative 10.5, yeah, okay. So negative 10.5 is our acceleration. Now, I want to find when it reaches its topmost point. The reason I want to do that is then I can find out how far it's got to travel before it hits the ground. So the distance that it will travel will determine the speed with which it hits the ground, of course. So let's go, all right, at the top of its travels, v is equal to 0. Why is v equal to 0? Because the acceleration due to gravity and the resistance have slowly cut down the velocity, and it's about to turn and go back down again. So I'm going to use v squared is equal to u squared plus 2as. Now I know v squared will be 0. My initial speed according to the question was 10, so 10 squared plus 2, and I know my acceleration is negative 10.5, and now I can find s. I rearrange my formula and I get s is equal to 100 over 21. Alright, so that's how far it's travelled up. Now, let's consider the downward motion. When we're going down, we have a force due to gravity pulling us down as before, but this time we have resistance this way in the opposite direction. So the overall force is going to equal mass times acceleration, and the overall force is going to be, let's take the down direction as positive in this case, 3 or 0.3 g, subtract 0.15 because that's in the other direction, equals m a. Now actually we know that m is 0.3, that's the mass, so I'm going to chuck that in 0.3. Alright, so we get 3 minus 0.15 is equal to 0, I forgot my acceleration there, 0.3a. Let's arrange this. A equals 3 minus 0.15 divided by 0.3 is 9.5 meters per second in the downward direction. Okay. Now, we know at start u is equal to 0 because u is now what we had over here when we were at the top of its travels. That's where we're starting from. Okay, so we want to know v, the speed at which it hits the ground, is going to be equal to u squared plus 2 times 9.5, and now we know s, it's what we found in the first bit plus the amount that we are off the ground in the first place, which is 1.2 according to the question, right? So we threw it up, we were 1.2 above the ground. So I found out how much it went up above where we started, and then I'm adding the 1.2 onto it. Now, when we work this out, we're going to get v is equal to, let's have a look, 2 times 9.5 times 100 over 21. We've got a bracket there, plus 1.2, closing the bracket, square root. We should get 10.6 as our velocity with which it hits the ground. Okay, I'm pretty happy with that. That seems good. Let's move on to one final question. Come back. Okay. See how we go with this. A bouncy ball is dropped from a height of 5 meters. When it bounces, its speed after the impact is 80% of the speed immediately before the impact. Find the maximum height of the ball after bouncing. Okay. So for this, let's see what we know. It's dropped, so we know that u is our initial speed is 0. We want to find v when it hits the ground. And I'm going to take my acceleration as equal to 10. I'm just going to go with the direction downwards as my positive direction for this. And then we know that s in that case is 5. So we can go ahead and use v squared equals u squared plus 2as to figure out what our speed is with which it hits the ground. So I'm just going to chuck in my variables here. 2 times 10 times 5. So v squared is equal to 100. Ah, that's nice. So v is equal to 8. Oh, sorry. I'm jumping ahead of myself here. V is equal to 10. Now, so that's when it hits the ground. Now we know that after it hits the ground, it's 80% of the speed. Okay, so after bounce, what do we know? We know that we've got an upwards speed is going to be 8. 80% of 10, right? We know that we want to find out the maximum height. Well, we know the maximum height will be when it reaches v equals 0, because that means gravity has reduced the speed to 0, so that it's about to start going down again. In that case, we want to know this, and we know that acceleration is going against the direction that we've got our velocity of u. It's working against that. So we're just going to chuck in the same formula again, I think. We're going to go 0 squared equals 8 squared plus 2 times negative 10s. So we get 0 is equal to 64 minus 20s. So 20s is equal to 64. So s is equal to 64 over 20, or we could say 3.2 meters. That is its maximum height after bouncing. Now, for the last part of the question, show that the height is independent of the value used for g. There's a couple of ways you could do this. I'm not going to delve into that, but you could try different values of g and see if that makes a difference. Or you could prove by algebra that that is an irrelevant variable. But either way, it's fairly doable. So well, if you want me to show you, I can do that at a later date, but I'm going to call this video to a close at this point, because I think I'll probably have time to go over some more questions in Zoom with you as well. Alright team, good luck.